Hey guys, hope everybody's doing all right. So this the second part of section 4.3 talks about the fundamental theorem of calculus. Just by the naming of it, it's pretty important. So I'm not going to really read through this first part here, just because I think it'll make a lot more sense if I just kind of work through an example, and then you'll kind of get the idea of what it is based off of that. So this first part says that capital F of x is the integral from 3 to x of t squared plus t plus 1. Okay, so what we're going to do is we're actually going to figure out what f of x would be equal to. All right, so we're going to actually find the definite integral of this equation, and then what we're going to do is then once we have that answer, then we're going to find its derivative, and you should see a pattern that comes from that. Okay, so the first thing that I need is my antiderivative, right, which would be t cubed over 3 plus t squared over 2 plus t. Okay, and then I'm going to go from 3 to x. Okay, so anywhere I see a variable of t, I'm going to replace it with an x term. Okay, so this is now x cubed over 3 plus x squared over 2 plus x, right? Anywhere I saw a variable, I replaced it with x. Okay, and then I'm going to subtract when I plug in 3, okay? So 3 to the third is 27 over 3 plus 9 over 2 plus 3. Okay. All right, so now I just need to simplify. So I have x cubed over 3 plus x squared over 2 plus x. Okay, and then here I have 27 over 3 is 9 plus 9 over 2 plus 3. 9 and 3 gives me 12 plus 9 over 2, and then 12 is 24 over 2 plus 9 over 2. Okay, so here at the end, if I just keep bringing this down, this ends up giving me x cubed plus, this ends up giving me x cubed over 3 plus x squared over 2 plus x, and then 24 plus 9 is going to give me 33 over 2, so minus 33 over 2. All right, so off to the side here, I'm going to say that at big f of x is x cubed over 3 plus x squared over 2 plus x minus 33 over 2. Okay, so that's our new equation. Okay, so we took the integral of our original, which was t squared plus t plus 1, and then our definite integral gave us our new equation. Okay, now if you take the derivative of what you just found, okay, so take derivative of f of x, right? So we're going to call that f prime, right? I'm going to bring down the 3 for my first term, right? And the 3's will cancel each other out, so, right? So that's going to give me x squared plus x plus 1, and then obviously the derivative of a number just becomes 0, okay? Now, what do we notice, right? If you look back with what we started with t squared plus t plus 1, right? And then what did we find? We figured out x squared plus x plus 1, okay? So I know obviously the variables are not the same, but we technically have the same equation, okay? So what you should notice from that is that when you take the integral of something, right, and then take its derivative, you're ending up with the same thing, okay? So that pretty much just tells us that derivatives and integrals are opposites of one another. Okay, I'm sure you guys probably could figure that out just by how the year has gone. But so they are inverse operations. Okay, same way that like addition and subtraction are inverse operations, multiplication and division, we have the same thing for integrals and derivatives, right? One is going to outdo the other, okay? So when we're doing this process, okay, we can actually, we can really just skip all of these steps here, right? And if I know that I'm starting with a variable of t, but if I see a variable of x in my definite integral, right, I can immediately replace that right into my equation, okay? And that will give you the answer. So it's like you're, if you're on a ladder, it's like you're going up one step when you do the integral, but then when you take the derivative, you go back down a step, okay? So you're ending up where you started, okay? So that's pretty much what this definition is saying, is that if you take the derivative of an integral, okay, which is what we have here, what you're going to be left with is just the original function. Okay. So these are pretty easy. I think they look kind of complicated, but they're really not. So what we're going to do is to go through this process. It's a pretty easy concept. So I'm taking the derivative of my integral equation. Okay, so I'm going to replace anywhere I see a variable with what I have up here first. Okay, so that's going to give me x squared minus 3x plus 1, okay? And then what we're going to do is we're just going to multiply by the derivative of what we just plugged in, okay? So here we're plugging in x, so the derivative of x is just 1, okay? And then we're doing a definite integral, so I have to subtract the second part, okay? So I'm going to plug in now 1 anywhere I see a variable. So I have 1 minus 3 plus 1, okay? But then I need to multiply by the derivative of 1, which is just 0, okay? So the nice thing about this is that the second part just goes away. So then your final answer just ends up being x squared minus 3x plus 1. Okay, so we're moving on to the second one, okay? So again, the derivative of the integral, so I'm starting with going from 5 to x. So I have x cubed times sine of x, okay? And then that whole thing is being multiplied by 1, because that's the derivative of the first term, okay? And then minus, plugging in 5, so the square root of 5 cubed times sine of 5, okay? And that whole thing is being multiplied by now 0, because that's the derivative of 5, okay? So the second term will cancel, so then you're just left with square root of x cubed times sine of x. Okay. All right, now the third one, again, we're plugging in the top limit, okay? And then we're going to multiply by its derivative, all right? So you have e to the x times the square root of x plus x squared divided by ln of x, okay? And that whole thing is going to be multiplied by 1 minus, then you got e to the pi times the square root of pi plus pi squared over ln of pi, times, now the derivative of pi is just 0. Okay, so that second term goes away. So you're just left with e to the x square root of x plus x squared over ln of x. Okay. So this fourth one, now the number is the top one first. Okay, so the process here is not going to change. Our answer just is going to be a little bit different. So again, I'm going to plug in the top number first. So I have the fourth root of 2 to the third minus 2 squared plus 1. Okay, and I'm going to multiply that by 0 because that's the derivative of 2 minus, you got the fourth root of x cubed minus x squared plus 1. And then the derivative of x we know is just 1. Okay, now the first part is going to cancel because we're multiplying by 0. And then your answer is just going to be negative fourth root of x cubed minus x squared plus 1. All right, so the only difference here is because x is now the first limit instead of the second limit, your answer is just going to be negative. All right, so if again you see the next one, 10 is at the top and then x is on the bottom. So if I plug in 10, I got 10 squared minus 1 over 3 times 10 squared plus 4 times 10 minus 2. All right, multiplied by 0, because again, the derivative of 10 is 0, minus, plugging in x, so that's x squared minus 1 over 3x squared plus 4x minus 2 times 1. So that'll cancel, and then you just got negative x squared minus 1 over 3x squared plus 4x minus 2. All right, so as you're doing this, like the derivative part is canceling out the integral part. Okay, so that's why you're ending up with really the same function that you have on the inside. It's just that the variable is now changing from t and going to x. Okay, now what happens if it's not just x to the first, right? How is that going to change our answer a little bit? Our process isn't going to change, okay? We just have to pay attention to what we're multiplying by, okay? So for this one, we're starting with 2x cubed, okay? So I have sine, now instead of sine of t, I have sine of 2x cubed, okay? Now I need to multiply that, this whole thing here, I need to multiply that by the derivative of 2x cubed, right? Which is just 3x squared. Okay, and then minus, we have sine of 1 times the derivative of 1, which is just 0. Okay, so this part is going to cancel. So your final answer now is 3x squared sine of 2x cubed. Okay, so this one's a little bit different because our upper limit now was not just x to the first, it was 2x cubed. Okay, so you just don't want to forget about that chain rule part. Okay, so for this one, I see that my one limit is going to be e to the x. So it's going to make my answer a little bit different than just plugging in the x term. Okay, so you have 7 squared plus 5 times 7 times 0, derivative of 7, minus, okay, now e to the x squared plus 5 e to the x, okay? Now the derivative of e to the x is itself, okay? Now this first part cancels, okay? So now we're going to have negative, now e to the x squared becomes e to the 2x plus 5e to the x times e to the x. All right, so what I'm going to do is I'm just going to distribute now. So e to the 2x times e to the x, right? We're going to add our exponents together. So that's going to give me e to the 3x plus 5 e to the 2x. And then we just have that negative out front. So negative e to the 3x minus 5 e to the 2x. Okay. Trying to look at a couple of these other ones. If all right, let's do we'll do C and D. And so for letter C, right, I'm doing 3x squared plus 1. Okay, so I have the square root of e to the 3x squared plus 1. Okay, and then that's going to get multiplied by the derivative of 3x squared plus 1, which is just 6x, minus square root of e to the 4th plus 1 times derivative of 4 is just 0. So that goes away. So my answer is just going to be 6x square root e to the 3x squared plus 1. Oop, I forgot that up here. Plus 1. All right, and then the last one that we're going to do, all right, we're going to plug in 5 first. All right, so you got 5 to the 4th plus 1 to the 1/3 times 0 minus x cubed to the 4th plus 1 to the 1/3 times 3x squared, right? That's the derivative of x cubed. All right, so this is going to give me negative 3x squared times, now x cubed to the 4th power becomes x to the 12th plus 1 to the 1/3. All right, so as you guys can see, right, it's not really a ton of steps. It's just following the process each time. So you just don't want to make sure you forget that you're plugging in when you're doing like the chain rule part. Don't forget you're doing the derivative of what you're plugging in. Okay, so if you guys have any questions, let me know. Thanks.